technology. So today I'm going to take the DT-based lecture video in the subject design of transmission systems. So we already know that the design of here specifically we are going to see about the transmission elements design. So we already know that the design is very important criteria for each and every research and development products in our today's scenario. So whatever may be the artificial intelligence, it will be impact more in the industrial sector. Beyond that, manufacturing also is equally important nowadays. So before we are manufacturing any component, any products, we should design the component. That prototype model is very important. So that's why we already in our curriculum itself we are following the design thinking framework, which consists of the empathy, define, ideate, and prototype and testing. These are the five stages of design thinking framework, which combine to develop the product is much better way. So not only product in the product point of view, in our teaching the subjects, in each and every subject in classroom point of view also, we are dealing with the design thinking framework approach. So here in this particular subject, design of transmission systems. So the continuation of design of machine elements. So design of machine elements and transmission system, it will be a totally overall, it will be very familiar subject, and it is also very important subjects in mechanical engineering students. So these are all the very core subjects. Okay. So that's why we are giving that much of importance of these particular subjects. So before we are going to see that the transmission systems. So we already know that the design of the component is very important. So that based upon the component design only, that end product we can get in a very good manner. So that's why we are giving a design of transmission system and machine elements will be a very important topic. So if you are going to design the component, there are a lot of the geometric properties we are using. Okay, so each and every component design it will be very different. So here the transmission elements it will be combined of there are a lot of transmission elements we are using here. So belt, in the belt also there are various classifications are available. The flat belt drive is there, V belt drive is there, and then chain drive is there. So these are all the each and every belt and the chain drive design procedure also will be different. So and also here we are going to see the spur gear. The gear design is also different. That gear also in this particular curriculum we are going to see that spur and the helical gear design. So these are the design procedure. It will be for transition components is much familiar to use our data book. So data book is nothing but PhD design data book. So it will be very important the book which can combine with these data. So that's why here itself we are representing here the PhD 8.5, PhD 8.5. So like that page number, that point is very much, we need to mention over here. This is a design procedure. We just want to mention over the what is the page number, we just want to refer to take this particular value. So that is the thing. Okay, so that's why from the data book we are getting a technical values, geometrical values from these for what are the components we just want to take to design. So that's all. So for that particular introduction, that stage. So now we are going to see the particularly we are going to see the design of spur gear design. So here these are all the data will be given from the problem. Okay. So normally they are given a power. In the kilowatt we are given 22 kilowatt, and the speed they are given n. The representation of n, the notations. Each and every values we just want to give the notation. So that only it will be easily we just want to get those value from In that, we just want